Welcome to Banks and Markets. This is Binam. This is the third video on measures of return, and I'm continuing with the same numerical examples. We already spoke about how we can find holding period return and how we can also obtain geometric mean and different ways of calculating geometric mean, also including the Microsoft Excel function geomean is what we did. And then we also talked about the differences between the arithmetic mean and the geometric mean, and in the last video we also talked about cumulative return. Now I will talk about the log return. So we've got these investment amount which are changing values because of the rate of return earned in each week. So now from this, what we can do is apply the natural logarithm function, which is equal ln, and then find out this rate of return applying natural logarithm. So it's very much similar to what we had mentioned before, but there will be a small decimal changes. So let me first find this for all the amount. So we've gone all the way up to here, which is week 11, and now let me also change the format to that, and you will see that they do not differ much, but when I increase the decimal places, you will see that there is small differences between the two. Okay, so here 0.0283, here 0.0284, here 0.2, here 0.1998. Of course, not a big change though. What we would like to do now is find out the returns using these using these returns that we computed using the ln function. So here what I will do is put additional information, which is exponent of log return. Okay, and therefore now over here what I can do is equal, that's the function in Excel, exp, and then I'll take the average of all these returns that just computed, and I'll close the bracket, and I will need another bracket, take away 1. So this is what I have done to get exponent of log return. Of course I can change the format now into to limit the number of decimal places. So format changing to make it consistent is this. So you can see exponent of log return, the way I have done is again giving me the same thing as that of geometric mean. So this then basically mean I can again do what I was doing before to analyze So 52 take away 1, assuming 52 number of trading days in a year. So therefore we find this value here, and therefore I can again put that information, which is analyzed return using natural log. Okay, that function we used. So now we found this. What we can do now is see these changes when we increase these returns. Okay, so let's say this in week 8 I change it to 0.98. okay, this means the information in column D, the amount will also change, and therefore this will also change, and subsequently all values here are also going to change for geometric mean and arithmetic mean. So changes are taking place. So geometric mean annualized is 8.127, annualized is 8.148, but the one using the natural log is exactly similar to that of geometric mean. Okay, so thank you for watching, and maybe very quickly I can also talk about others such as mean, median and mode here, which is very simple, but they are also mean, mode, median. In fact, mean we've already found, which is the arithmetic average, so I can simply take arithmetic mean, and for the mode I can click equal mode, and therefore I can take these return, and that's it. And the final one is median, and therefore we have the median number here. So we can see that we can obtain different values. Of course, these are all related to returns, and we wanted to emphasize the fact that for finance investments, geometric mean is more important than arithmetic mean. Arithmetic mean useful, good, and also captures when there are big outliers, but for investments, given the nature of returns and when we've got time periods, then we can apply geometric mean. This was just mean, mode, median, which we all know. All right, thank you very much for watching, and I'll be continuing my discussion related to how we can evaluate performance of a portfolio or investment such as this, and in the next video I'm going to talk about the risk aspect. So far we've been talking about the return such as holding period return, geometric mean, arithmetic mean, mean that we can find out using the natural logs, which is going to give us the numbers similar to the geometric mean. And now it is time that we talk about the risk aspect, and together with risk and return we can find out different risk adjusted return values. Thank you.